Hello Algebra 2 folks, how we doing today? So I'll just get going on this review here. So z varies directly with the square of x, so I'm going to put that constant of variation in there, that's the k, and then the x squared, and inversely, so that means it's going to be over y. So there's your part A, so that's the function. Now it says find that constant of variation, so it gives us all the letters except for the k, so we're just going to plug those in. So it looks like z is 10, we don't know the k, x is 2, and that's going to get squared, and then that's over y, which is also 2. And then I'm just going to go horizontal here. So we got 10 equaling 4k over 2, and that means 10 equals 2k, and then divide away the 2, and we get 5 to equal k. And then part C is just rewriting this but putting the 5 in. So part C will just be z equals that 5 for the k, x squared all over y. So there's the first one without the k. Here's the work to get the k, and then here's putting the k in there for the final thing, the final function. And now it wants to find z if x is 3 and y is 5. So z is going to be 5 times that 3 squared, so the x gets squared, all over the 5, which is y. So the 5's cross out, that makes it easy to calculate. So 3 squared gives 9 for z. Alright, this next one now, this is without a calculator. Sketch and label the asymptotes and graph this function. So it's going to be an inverse variation here with a slide 2 to the right. So that tells me that there's going to be a vertical asymptote at x equals 2. That's what zeroes it out here on the bottom. And then this is bottom heavy, so that means it will have a horizontal asymptote, and it gets, normally it would be y equals 0, but then this plus 4 shifts it up so that we get another horizontal asymptote, and that's y equals 4. So when it says label the asymptotes, that means just write the equations down for those. And then I'm fine with you guys finding a couple of points on your calculator. If you put a 1 in for this one, you get 7, so that's a nice point. And if you put a negative 1 in there, you get 5, and that's close enough for this sketch because we know the asymptotes. We'll just branch that out like that. And then there's the other piece. If you put a 3 in there, you get a 1, and if you put a 5 in there, you get a 3, and that's enough for us to get the second branch of our inverse variation. And that's as accurate as you need to be. Just get a couple of lattice points and you're good to go. Alright, next one here. We've got it all factored, that's nice. And it says find points of discontinuity. So those are all the zeros of the denominator. So I get x equals 2. That'll zero out this first one. A negative 5 will zero out this middle one. And a negative 1 will zero out the last one here. Don't care about the zeros up top, although they do match. Now vertical asymptotes, that would be when there's just it on the bottom. If it's on the top and bottom, like the x plus 5s and the x minus 2s, those are going to be the holes. So the only vertical asymptote is that negative 1 value for x. And then the holes, those were the 2 that had top and bottom of the same factor. Horizontal asymptotes, this is degree 2 on top. If I multiplied these two linear binomials together, I'd get x squared as my lead coefficient. Downstairs I'd have x cubed, so it's bottom heavy, telling me that y equals 0 is going to be a horizontal asymptote. So the sketch for this graph now, I'll move this over just a little bit. I'll put in this x-axis y equals 0 asymptote. and then the x equals -1 vertical asymptote. And then we've got holes at 2, so there's going to be a hole right there, and we have a hole at -5, so a hole right there. Kind of hard to see when it's right on the axis there. And then the sketch will have one branch with a hole in it on the top, and we'll have one branch with a hole underneath the axis. And that's as accurate as you need to be on these. Alright, these last two require us to do some factoring and restrict any zeros that we find, any points of discontinuity. So in this top here, for number 4, what times what makes 8? That would add to 2, and that's going to be a y plus 4 and a y minus 2 in whichever order. And then downstairs we can only do a GCF factoring, but we can get a y plus 4 as one of those two factors downstairs. The y is the other one. Now once these are products, then I can cancel these out. So goodbye the y plus 4's, and that leaves me with y minus 2 over y. And then this is the part that's really easy to forget. Don't forget to put the restrictions. What values of y would make this denominator equal 0? And there's 2 of them. So the 2 restrictions would be y cannot be 0, that's for this y here, or a -4. Either one of those would cause this denominator to equal 0, which we have to restrict. Whoops. Oh, it's almost done here. Alright, I'm going to do some factoring first on this next one. We've got difference of 2 squares, so I've got y minus 6 and a y plus 6 for the numerator of that first one. Y cubed, there's nothing to factor there. The 4y to the 5th, nothing to factor there. But downstairs I can get y plus 6 and a y minus 2 for my 2 factors on that one. And now I can do cancellations, whether they're in the same fraction or in these 2 different fractions. I can cross cancel these. So y to the 3rd, y to the 5th, I can use my power rule on that, subtracting 3 from this and getting y squared on top. There's 5 y's up there, there's 3 y's down here, so it ends up with just 2. The 4 will stay up there. The y plus 6's, they disappear as well. And that's it, I think. So we got a 4y squared on the top, and in parentheses a y minus 6, and then all over a y minus 2. And then again, don't forget those restrictions. So I got y cannot be, and then anything that would make it 0 in the denominator. Well, 0 is one of them. The y plus 6, that gives me a -6, is the point of discontinuity, and a positive 2. And these in any order. So there's your final answer. Alright, 1 page down, 1 to go here. Oops, I'm going to move this the other way. Where are we? Here we go. Alright, now division. This is one that can be a little confusing, so we have to restrict all the things in the denominators that we start with, and when we flip this and use our multiplication is the same as dividing by the reciprocal idea. Dividing by the reciprocal is the same as multiplying, I should say, better, that this y is going to have to be restricted. So the only thing that's not restricted is this first numerator in a division problem. So let's do the factoring and the flipping first. So the y squared, this first fraction, that's just going to be factored into a y plus 8 and a y minus 2. So I'm going to have to restrict both these, and then I'm going to keep change flip this, and this is going to be a y plus 2 and a y minus 2 when I factor the difference of 2 squares, and then the 2y downstairs. Alright, and then we can look for some cancellations, hopefully. So it looks like our y minus 2's get crossed out, and then there's a y to the first downstairs and a y squared up. So I use my power rule, subtract 1 from 2, that gives me a 1 up there. The 2 stays downstairs. So that looks like all the cancellations I can do. So I've got a y on the top and a y plus 2. And then underneath I've got a 2 and a y plus 8. You could multiply those out, but it's probably better just to leave them like that. And then, of course, don't forget the restrictions. I'll put these underneath. So y can't equal, so it can't be a negative 8 or a positive 2. That's from this first fraction. It can't be a 0. That's from flipping that 2y downstairs. And it also can't be a negative 2. And if you wrote plus or minus 2 in the restrictions, that'd be okay also. So there's our final answer for that one. All right, least common multiple, same idea as least common denominator. We need to have all these quadratic trinomials factored so we can see if there's any common factors there. So the t is good on the outside. This is going to turn into a t minus 7 and a t minus 2. This is a positive 14, so they're both the same sign. Negative 9 makes it both negative signs. What times what makes 14? That adds up to be a 9. And that's the 7 and 2. Same idea over here. The t to the 7th, that's good. This one is going to be what? T to the positive, t plus 4, and t minus 2. That'll get us a positive 2 for our middle term and a negative 8. Now the LCM, we've got to be able to build both of these with the least number of things. So I'm going to need a t to the 7 to make this one. That'll cover this t. I'm going to need a t minus 7 for a linear binomial, a t minus 2. That allows me to build this first one because there's 7 t's out there, so that covers that 1 t. Now I need to have a t plus 4 in here. The t minus 2 I've already got from the previous one, and the t to the 7th. So there's my LCM. It's just like a least common denominator, only without a fraction. So I got 3 binomials plus the t to the 7th for that one. All right, 8 through 10, it doesn't say state restrictions, so we won't have to worry about those zeros or points of discontinuity. But adding fractions, you have to have the same denominator. We don't. It's close. We have an x minus 4 and an x plus 4. So actually, multiplying those two together is the only way to get a common denominator. So in this first one, I'm going to multiply top and bottom by x plus 4. So x minus 4 and then x plus 4. Notice I'm just multiplying this original first fraction by 1. It's just a fancy one. X plus 4 over x plus 4. Then I have a plus sign, and I'm going to do the same thing, but now I have an x plus 4 there already, so that means I'm going to have to multiply by x minus 4 top and bottom. That keeps it fair. That gets me a common denominator. I'm just going to leave it like that. X minus 4 and then x plus 4. And then I'm going to put together some like terms. So I got 8x squared. No like terms with that. Oh, there is. 8x squared plus 32x plus x squared minus 4x. Now I'm going to put together those like terms. So I get 9x squareds. Sorry, this is getting a little small. 32 minus, that gives me 28x's. And then over that x minus 4 and x plus 4 denominator. So there's your final result right there. All right, difference of two squares, subtracting, and then just y minus 5. So that tells me I'm going to need to multiply top and bottom by y plus 5 for number 9 here. This first fraction, it has the least common denominator already, so I don't have to change that at all. I will just show it as y minus 5 and y plus 5. I can make this all one big fraction now, minus. Then I'm going to have to distribute 6y to y. That gives me minus 6y squared. And I'm going to have to distribute negative 6y to the plus 5. That gives me negative 30y. Easy to miss that minus sign right there. There are just a couple of like terms, this 1y and negative 30y. So I can put those together, which gives me negative 29y's. And then it's all over that common denominator, minus 5 and y plus 5. Certainly you could have had that multiplied out or factored a little different here. For example, you could have had this be negative 6y squared minus 29y all over y squared minus 25. Either one, probably the factored version, a little bit easier, especially if you're going to be dealing with graphing. All right, number 10, a complex fraction. So the top I don't really have to monkey with in the first move. That's going to be all right. But here I've got to make this a common denominator, so I can put the 4, excuse me, with the 7 over y plus 2. So I'm going to do that. 4 y plus 2 over y plus 2 times that. Just changing that so I can put these two fractions together. So it's going to be 4 times that y plus 2 minus 7 all over a y plus 2. So basically I've got that 4 so that it has a common denominator. They're both over y plus 2. That's nice. I could multiply both of these by y plus 2 over 1, top and bottom, and the y plus 2's will cross out. I get a 9 on the top, and then I have to distribute and combine like terms here. So I get what here? 4y plus an 8 minus a 7. And then that can be put together to give us the final answer of 4y plus a 1. All right, got some equations to solve here now. First one is a fraction equaling a fraction, so cross products is my favorite way, so I'm going to do 2 times this. Now remember, these binomials, the fraction bar acts like parentheses. That's a parenthesis there. So when we do this, we have to distribute, so you don't get just 2x minus 15, you get 2x minus 30. The 2 has to be multiplied to both terms. Same with the 4. So you get a 12x minus 20. And now it's a stupid line problem, getting numbers to one side, variables to the other. I would probably subtract 2x from both sides. That'll get me the 10x here. And then at the same time I'm going to add 20. And that gets me a negative 10. Divide away the 10, and I get negative 1 to be x. And that's the only possible answer, but we don't know it works yet. So you have to go back to the original equation and see if that negative 1 is going to cause any problems with making zeros or not working with the square root, something like that. So I'm just going to do that. 2 over, and then it's a 3 times a negative 1, subtract 5. Do I get the same thing if I do 4 over a negative 1 in there for x, subtract 15? Well, this makes 2 over negative 8, and this makes 4 over negative 16, and both of them equal negative 1/4, so that checks. So x equals negative 1 is a solution to this equation. It works. All right, this middle one here, number 12, I can get rid of the x squared and x by multiplying the entire equation by that least common denominator. Remember, this 1 could be over 1, so 1x and x squared. What's the least common multiple of those 3 terms? That is x squared. And so now I have to bomb the equation. So there's 3 terms in this equation. I'm going to do x squared times each one of them. X squared times the 1 gives x squared. X squared times 3 over x, the x and x squared, I use the power rule on that. This is x to the first, so I would subtract 1 from 2. That gives me an x times 3 gives me a 3x term. And then the x squares out on this side, and I get just a 4. And now I need this to be 0 to solve this with a quadratic. You could go to the quadratic formula right away, or you could try factoring for a little bit. And this one is factorable. So x and x there. What times what makes negative 4? That would add to 3. That would be a plus 4 and a minus 1. And then we can use our zero product property. So x is going to be either negative 4 or 1, and we have to check both of them. All right, so first check here, make a little separation. First check, 1 plus 3 over 1, does that equal 4 over 1 squared? Well, 1 plus 3 over 1 is 4. 4 over 1 squared is 4, so that works. So 1 is a solution. And we're going to do the same thing again with the negative 4. So 1 plus 3 over negative 4, does that give me the same result as 4 over negative 4 squared? Now remember, when you put that negative 4 in there and square it, that gives you a positive 16. So I get 4 sixteenths on that side. 1/4 minus 3/4, that's 1/4. 1 is 4/4. And yep, those two are equal. So both of these solutions work as well. All right, one more of these. So you could make this a common denominator and then do cross products, or you could do the multiplying by the least common denominator. That's going to be my preferred method here. Either way would work. And so again, I got to bomb all three terms by this least common denominator of x minus 2. So it's nice, the x minus 2's cross out, and I just get a 10 for this first one. Then I'll have x squared minus 2x. I'm going ahead and multiplying this out. So I just did the x minus 2 times this x term. And then I'll have x squared plus 3x on this side, because the x minus 2's will cross out. Well, nice, the x squareds cross out as well. So now I've got 10 minus 2x on the left and a 3x on the right. Now it's a two-stepper. Move that x over, and I get 10 equals 5x. Divide away the 5, and I get 2 to be x. All right, the check. Right away, there's a problem. I get 2 minus 2 in the denominator, so x cannot equal 2. So there's no solution for this problem. All right, last one. Huey can clean the duck house in 7 hours. Dewey can clean it in 5. How long will it take them to clean the duck house if they work together? So that goes back to this t over a plus t over b equals 1 equation, where t's the time working together, a and b would be the solo time. So Huey would be a, let's say, and Dewey would be b. So I'm going to do t over 7 plus t over 5 equals 1. And then a quick, you could get common denominator 35 and work it out like that, or multiply everything by 35 and make the fractions disappear right away. So 7 goes into 35 5 times, so I get a 5t. 5 goes into 35 7 times, so I get a 7t, and that equals 35. Don't forget to do it to all three pieces when you do this trick. That gives me a 12t equals 35, and then divide away the 12. And that gives me t equaling 35 twelfths, which would be 2 and 11 twelfths hours, or if you wanted to say 2 hours and 55 minutes. Hours or minutes, either way is fine. All right, good luck on your last test for this course. Hope everything's going well at home. Best of luck to you. And of course, have a great day and do everything your parents say.